Now for the last part of this question, we're told that on a single diagram, sketch the TV graphs for the two particles, with t equaling 0 as the instant of their initial projection. And what I've got here is a sketch basically of the problem so far. Remember that particles P and Q were 3.6 meters apart. P was projected towards Q with a speed of 4 meters per second, while Q was projected towards P with an initial speed of 5 meters per second. And then they collided at 0.4 seconds. We found that out in part B here. And we also found out that after they collided, we're told that P was at rest and it's Q that moves off to the right at 1 meter per second. So, as I say, we're asked to draw this single diagram of a TV graph, okay, for the two particles. So if you'd like to have a go at this now, I'll give you a moment just to pause the video. Do come back when you're done. You can check your work solution against mine. Okay, welcome back if you had a go. So to do this, let's just set up our axes, okay? We'll have our V for velocity here, okay? And we'll have our time running across here. Okay, so it's t is measured in seconds and v is measured in meters per second. Let's start with particle P. We'll do that in red. Now for particle P, it starts when t equals 0 at a speed of plus 4 meters per second. So we'll have 4 then up here. Take that as being 4. And it's moving with a constant speed. So we'll just have that going across then horizontally like so. Then it hits Q after 0.4 seconds. So let's just mark this point here as 0.4. Now at this point, it immediately comes to rest. So what we've got here is just directly below this, okay, it's just going to continue at rest. I'm just going to draw that red line just slightly above the axis so you can see it. In theory, it's right on that line, okay, following on where V equals 0. So that's P. Let's just have a key here, and that then represents P. Okay, so we'll have that as our key. Now we'll look at the motion of Q. We'll do that in green. Now it's moving with a speed of 5 meters per second, but its velocity would be in the opposite direction to what we've got here for P. So it's going to be -5. So what we'll do is we'll start down here now at -5. And it moves at this constant speed until the collision, till we get to a time of 0.4 seconds. So that's going to be a horizontal line across here. Now at 0.4 seconds, the speed is 1 meter per second, but it's in the opposite direction. So it's now +1. So what we've got to do here is take +1, let's say it's there, and we'll bring this up through here. I don't think it matters if you don't put that dotted line in, but then it's going to continue at 1 meter per second, okay? And that's for our particle Q. Okay, so we've got a TV graph for both particles drawn.